Welcome all to the world of maths. This is KRISY'S and you're watching my YouTube channel KRISY'S Maths Academy. So, in my previous 3 videos, I have discussed about number series, AP that is arithmetic progression and GP that is geometric progression. So, in this video, I am going to discuss on the problems of these topics. So, if you want to know about these topics, please check into my previous videos. I will add the link in the description box. Okay, so let's go to the first problem. So the first problem is how many 3-digit numbers are divisible by 6? So in this question we have to find 3-digit numbers and it should be divisible by 6. The sequence of 3-digit numbers. So first let's see 3-digit numbers. Okay, the first number will be 100, 100. So it will be 100, 101, 102, etc. And the last 3-digit number will be 999, right? Okay, so out of these numbers, we have to find out which of these numbers are divisible by 6. Okay, so about divisibility. I already put another video on what is divisibility and divisibility test by small numbers such as 6. Okay, I will add that link of that video in the description box. So if you have any doubts, please check onto that video. So in this case, divisibility by 6. If a number is divisible by 6, then it should be divisible by 2 and it should be divisible by 3. So it should satisfy these two conditions because 2 into 3 we get 6. Okay, so let's check the first number. The first number is 100. 100. Now if a number is divisible by 2, then it should be an even number. That is, the ones place should be either 0 or 2, 4, 6 or 8. Then it will be an even number and it is divisible by 2. Now if it is divisible by 3, the sum of each digits should be divisible by 3. And once it satisfies these two conditions, it is divisible by 6. So let's check for 100. 100 is an even number, so it is divisible by 2. So we have to check if it is divisible by 3. Okay. So what I do, 1 plus 0 plus 0, I get 1. So it is not divisible by 3. So I can cross this out. The next number is 101, which is an odd number. It is not divisible by 2, hence it is not divisible by 6. Okay, now we have the next number, that is 102. 102 is an even number, so it is divisible by 2. Now let's see if it is divisible by 3. So I write 102 is 1 plus 0 plus 2. That is equal to 3. So 3 is divisible by 3, so it satisfies these two conditions, hence 102 is divisible by 6. So I will write out the sequence of 3-digit numbers which is divisible by 6. Okay. So the 3-digit numbers which is divisible by 6, the first number will be 102. Okay. What about the second number? We have to just add 6. Okay. That is 102 plus 6, I get 108, and again I need to add 6 to get the next number, that is 140. So I can write it out, 108, 114. What about the last number? We can try with the same divisibility test. That is, we'll start from 999 and then go to the decreasing order. So I'll write 999. It is an odd number, so definitely not divisible by 2, so not divisible by 6. I'll go in decreasing order. The next number will be 998. 998, it is an even number, so it is divisible by 2. So let's check if it is divisible by 3. Okay. So that is 9 plus 9 plus 8. Which is the sum of the digits. It will be 18 plus 8, which is 26. 26 is not divisible by 3. So it is not divisible by 6. Let's go to the next number. 997. It is an odd number, so not divisible by 2, so not divisible by 6. I cross it. Next number is 96. It is an even number, so it is divisible by 2. Now let's check the divisibility by 3. Okay, that is 9 plus 9 plus 6, which is 18 plus 6 equals 24. 24 is divisible by 3. Therefore, 996 is divisible by 2 and 3. So, it is divisible by 6. Okay. So, here I can write the last number as 996. Now, there is one more method in finding the first and the last number which is divisible by 6. That is, we are just dividing these numbers. Okay. Let's see, the last number is 999. So what I do is I just divide 999 by 6 and find out what remainder I get. Now 6 ones are 6, remaining 3, I get 39. 6 6 are 36, again 3, I bring down the 9. 6 6 are 36. So I get 3 as the remainder. So what I need to do is, I need to write 999 minus the remainder, I get 996. So 996 will be divided by 6 and it will be below this dividend. Okay. So let's see about the first number, 100. I do the same method, 100 divided by 6. Okay. 100, so 6 ones are 6. I get 40. 6 6 are 36. I get 4 balance. So we'll get the number which is below the dividend. Okay, that is below 100. So 100 minus the remainder will be 96. So but we have to get 3-digit number. So I need to find the next number of 96 which is divisible by 6. Okay. So I add 6. I get 102. So in that method also we can find the numbers which is divisible by 6. Okay. Now we have to find how many terms are there in this number. So first of all we have to find the pattern of this sequence. So we already know the next number is by adding 6. That is, if I add 6 to 102 I get 108, and again if I add 6 I get 140. So the pattern is add 6. So this progression is called as arithmetic progression. Okay. AP, arithmetic progression. So let's sketch out which all terms or notations we can get out of this sequence. We know the first term and then the common difference and the last term. So I am writing that out. First term A equals 102. Then the common difference D equals 6. Then the last term, or we can say the nth term, if the number of terms is n, that is an equals 996. So what is the question? How many terms? That is n. We have to find the number of terms n. So I already discussed the formula for an in an AP. That is an equals a plus n minus 1 into d. Now I'll substitute these values. That is 996 equals 102 plus n minus 1 into 6. Now I can bring this 102 from the RHS to LHS. This plus 102 will become into minus 102. That is 996 minus 102 equals n minus 1 into 6. 996 minus 102 is 894 equals n minus 1 into 6. Now these are two factors. I can bring the 6 down, it will become division if I bring 2 from RHS to LHS. So this will be divided by 6. So instead of directly dividing by 6, I can divide by parts. That is, if I see the numerator and denominator both are divisible by 2. Okay. So I am dividing 894 divided by 2. I get 2 4s are 8. Again 2 4s are 8. I get 14 balance. 2 7s are 14. Similarly, in denominator, 2 3s are 6. 447. Is it divisible by 3? 4 plus 4, 8. 8 plus 7 is 15. So it is divisible by 3. So I can divide this numerator by 3. 3 1s are 3. If I divide by 3, 3 1s are 3. So I get balance 14. So 3 4s are 12. So I get 27 balance. 3 9s are 27. So the answer is 149. So I can write n minus 1 equals 149. Okay. That is n equals 149 plus 1. So n equals 150. That is the final answer. So the number of terms, that is 3-digit numbers which is divisible by 6, will be 150. Okay, so let's go to the next problem. Okay, now the next problem is find the sum of the first 45 natural numbers. So we already know that natural numbers are the counting numbers. Okay, and we have to find, let me write it out. So set will be 1, 2, 3, etc. up to 45. Okay, now I have to find the sum of these. Okay, that is the sum will be 1 plus 2 plus 3 plus etc. plus 45. I already discussed our number series. The sum of n natural numbers will be n into n plus 1 divided by 2. Okay, so in this case that n equals 45. So I write n equals 45. So let's substitute and see. 45 into 45 plus 1 divided by 2, which is equal to 45 into 46 divided by 2. Now 46 is divisible by 2. So I'll divide and see. Okay. 2 1s are 2. 2 2s are 4. 23. 45 into 23. 5 3s are 15. 3 4s are 12 plus 1 13. 5 2s are 10. 4 2s are 9. 5 3 1. So 1035 is the sum of the first 45 natural numbers. Now let's go to the next problem. The third question is 2 square plus 4 square plus 6 square plus etc. 20 square equals question mark. Now we know the formula for the sum of the squares of natural numbers, but this is not continuous. Some terms are missing. That is the odd terms. And then let's see this pattern. We can take, see, you can check that. You can see that 2 is common in all these terms. So let me try to take 2 out of each terms. Okay. That is, it will be equal to, the first term I can write it as 2 into 1 whole square. Second term will be 2 into 2 whole square. Similarly, 2 into 3 whole square plus etc. 2 into 10 whole square, right? So out of this 2 square is common. So if I take 2 square, what will come balance? For example, 2 into 2 whole square will be 2 square into 2 square based on the law of exponents. Okay. So I can write it as 2 square into, I take it out common and I write the rest of the numbers. So this is the sum of the squares of 10 natural numbers. Let's write the formula for the sum of the squares of n natural numbers. That is 1 by 6 into n plus 1 into 2n plus 1, right? And in this case, n equals 10. So let's substitute this value and see what's the answer. 2 square can be written as 2 into 2. Then what we have? 1 by 6, then into 10 plus 1. What is 2n? That is 2 into 10, that is 20. So 20 plus 1. Okay, I can divide 6 by 2, I will get 3. Then 2 into 10 is 20. So 20 into 10 plus 1 is 11 into 20 plus 1 is 21 divided by 3. Out of this, which term is divisible by 3? That is 21. So 3 into 7 is 21. Now I have to multiply 7 into 11 into 20. 7 into 11 is 77. That is 77 into 20. I just remove the 0, divide into 2. I get 154. That is equal to 154 and add the 0. 1540 is the answer for this sum. Okay, so hope you understood, and if you have any doubts, please put in the comment section so I can help you. Okay, and then I'm ending this video with just 3 problems. I'll put more videos. I'll put more problems in the next video. So you have noticed that I discussed only on number series and AP. So in my next video, I'll definitely bring more problems and add GP as well. Okay, so and please don't forget to subscribe to my channel if you are not yet subscribed, and please click on the bell icon so that you will get notification on my next video. Okay, so see you in my next video. Bye.